thanks to several dedicated scientists and their teams of experts, powering the future of space exploration and Mars' surface are moving closer to a reality.
The reality of manned missions to the Moon, Mars, and beyond, underway in Nevada. The Kilopower reactor using Stirling technology, or KRUSTy, is a small nuclear reactor with a big job.
One of the drivers for this additional power, the need to using local resources and sort of living off the land to reduce the amount of supplies and material that we have to send to Mars to support the health and productivity of our crew.
Once completed, it will power astronauts' habitat, create oxygen, purify water, and make liquid oxygen and propellant for returning to Earth.
As a former astronaut, I can assure you that having reliable power sources is critical when venturing away from low Earth orbit.
The first phase in the KRUSTy experiment was completed at the NNSS. A news conference in Las Vegas provided an update on the experiment. Experts from NASA's headquarters and Glenn Research Center, along with Los Alamos, NNSA, and the Nevada National Security Site, gathered to share their success so far.
This partnership between NASA and NNSA, it's win-win because NASA is getting this game-changing prototype experiment and NNSA is getting a benchmark quality experiment that will be a vital part of obtaining nuclear data supporting our nuclear criticality safety program.
They answered questions from the media and the public nationwide and shared the journey of how KRUSTy was built on years of previous experimental programs.
We took a lot of lessons from those previous programs and applied them here to simplify, to streamline, and to make the project more achievable. And that's the path that we're on right now.
Those programs had limited success in the sense that they didn't get to a reactor test, they didn't get to fly. We started to look at reactor systems that were smaller. We desired simplicity above all. We chose test places such as the NNSS, where we had available infrastructure that we didn't have to go build new facilities.
There hasn't been any tangible progress in fusion reactor technology in decades. And what's exciting about this project is we've actually made some progress.
I can tell you we've done dozens of tests, full system tests at NASA to make sure that when we come here, we're fully prepared. And the only difference would be now we replace that electrically heated heat source with the highly enriched fuel, and then we use the nuclear heat to repeat the process.
These forces kind of combined that you see up here today, we've made tremendous strides because of the leveraging that's possible. But it would have tremendous impact in terms of enabling missions that really aren't achievable with some of the other available technologies.
The team will continue to conduct KRUSTy experiments at the NNSS through March 2018.